The jitter transfer curves for the SI5324 and the SI5326 jitter attenuating clocks are shown in this plot, along with the jitter transfer of an SI5338 clock generator, which is a wideband PLL with a loop bandwidth of over 1 MHz. As such, the 5338 will attenuate very little jitter. As a consequence, if a wideband PLL, that is a PLL with a very large loop bandwidth, needs to have low output jitter, it must be driven by a low jitter clock source. It is important to understand that the selection of an appropriate loop bandwidth value is application dependent. If the clock source already has low jitter, then a higher loop bandwidth might be suitable. However, if the input clock has significant jitter, a lower loop bandwidth should be considered. In these situations, the system-level jitter requirements need to be considered. Some networking standards establish a lower limit to the jitter offset frequency that needs to be taken into account, and therefore jitter below a certain offset frequency is either not considered or discounted. Examples of such standards include SONET, Optical Transport Networking, and Ethernet. However, some standards require loop bandwidth values as low as 0.1 Hz, for example, synchronous Ethernet. Video networks typically care about jitter that is down to 30 Hz because of video frame rates, which call for a loop bandwidth below 10 Hz.